Welcome to GeoMethod channel. Before the proof starts, look at the full problem statement. We have a right triangle with C equal to 5, angle B equal to 90 degrees, and A, B, C positive integers. The area equals the perimeter, and the goal is to find A, B, and C. Now focus on the geometry. This is a clean right triangle problem where geometry and integer arithmetic meet. Side C is fixed at 5, and the right angle at B tells us we are working inside one specific right triangle. Now add the arithmetic restriction. The side variables A, B, and C are positive integers, so parity will matter later. State the task clearly. Area equals perimeter is a given condition, and the problem asks us to find A, B, and C. Name the side opposite A first. Call segment B, C, equal to A, because that side will be the height in the area formula. Now name the hypotenuse B. The fixed base segment AB is side C, because it faces point C. Translate the area side of the condition first. With base 5 and height A, the area is 1/2 times 5 times A. Next, write the perimeter as the sum of all three sides, 5 plus A plus B. Set those two expressions equal. This single equation is where the geometry problem becomes an arithmetic one. Clear the fraction immediately. Multiplying by 2 prepares the parity argument without changing the meaning of the equation. Collect the A terms on the left and keep the hypotenuse term on the right. Freeze the cleaned relation. 3A minus 10 equals 2B. The right side is visibly even, and that is the clue. Because 2B is even, 3A minus 10 must also be even. This is the whole point of isolating B first. An odd multiple of a minus an even number is even only when A itself is even, so write A as 2K. Substitute A equals 2K back into the same relation, and the hypotenuse becomes 3K minus 5. Now return to the geometry. The right angle at B lets us use the Pythagorean theorem on triangle ABC. Substitute the three expressions directly. This line is the meeting point of the parity trick and the triangle theorem. Expand carefully. The square on 3k minus 5 creates the linear term that will eventually single out k. Cancel the matching constants and gather every remaining term on one side. Factor the polynomial. The algebra is now simple enough to read off the candidate roots. Reject the zero root because side lengths must stay positive. The geometric solution is k equals 6. Substitute k equals 6 back into the leg. Segment BC becomes 12. Do the same for the hypotenuse. Segment CA becomes 13. So the triangle is the classic 5, 12, 13 triple. Check the area first. 1/2 times 5 times 12 gives 30. Now check the perimeter. 5 plus 12 plus 13 also gives 30. Both target quantities are 30, so the proof closes exactly where we wanted. Area equals perimeter. Discussion 1 is about another, more general problem in our problem set and solution. The proof just found the side lengths for this C equals 5 problem. Now we step back and use that broader result to explain why 5, 12, 13 was not a lucky surprise. Here is the connection. In that more general problem, the task was to classify all positive integer right triangles whose area equals their perimeter. We are not going through that solution again here. We only need its high-level conclusion. The conclusion of the general problem is very small. Up to swapping the legs, there are only two such integer right triangles. Those two triangles are 6, 8, 10, and 5, 12, 13. That is the only information from the more general solution that we need for this discussion. Discussion 2 is about the current problem. This problem is not isolated from that general classification. Because the current problem fixes one side, segment AB, at 5, it selects the 5, 12, 13 branch from the two-solution list. Discussion 3 checks the same conclusion directly from the fixed side. Since C equals 5 and B is the hypotenuse, Pythagoras gives b squared minus a squared equals c squared, which is 25. Now factor that difference of squares. We have b plus a times b minus a equals 25. The positive side length factors must be 25 and 1, so there is no freedom left. Discussion 4 is the clean conclusion. The fixed side, c equals 5, is not just another given. It selects one survivor from a tiny general classification, which is why referencing the broader problem makes this one much clearer. Solving the two direct equations gives a equals 12, b equals 13, and c equals 5 again. So the story is clean. The calculation proves the result. The general problem explains why this branch appears. An area equals perimeter is the signature of that branch. If you enjoyed this solution, please subscribe to the channel and click the like button. Also, leave a comment with a problem you would like me to discuss, or with an alternative solution you want to share.